If p, q are real and p not equal to q, then show that the roots of the equation p minus q into x square plus 5 into p plus q into x minus 2 into p minus q is equal to 0 are real and unequal. That is, here we have to show the discriminant of the given equation is greater than 0. When the discriminant is greater than 0, then the equation has real unequal roots or real unique roots, or we can say real distinct roots. Here we have to show discriminant of the equation is greater than 0. And comparing this equation with ax square plus bx plus c is equal to 0, here a is equal to p minus q, b is equal to 5 into p plus q, and c is equal to minus 2 into p minus q. To take discriminant, b square minus 4ac, here b square 5 into p plus q whole square minus 4 into a is p minus q, c minus 2 into p minus q, which is equal to 5 square is 25 p plus q whole square minus, here minus into minus plus 4 into 2 8 p minus q into p minus q, p minus q whole square. Here given p and q are real and p not equal to q. It is given here p, q are real numbers and p not equal to q. That means here for any real numbers of p and q, p plus q whole square is positive. For any value p and q, we will get p plus whole square positive. Similarly, p minus q whole square also positive. So we can take 25 p plus q whole square greater than 0. Similarly, 8 into p minus q whole square greater than 0. Therefore, discriminant discriminant 25 plus p plus q whole square plus 8 p minus q whole square greater than 0. Because here 25 p plus q whole square greater than 0, 8 p minus q whole square greater than 0. That means when we adding these two, we will get the positive number that is greater than 0. So the discriminant greater than 0. That is, the given equation has real and unequal roots. Discriminant is greater than 0 means equation has real and unequal roots. Find the values of k for which the equation kx square plus 6x plus 1 is equal to 0 has real and distinct roots. Solution: here given equation has real distinct roots. That is, the discriminant of the given equation is greater than 0. Comparing the given equation with ax square plus bx plus c is equal to 0, here a is equal to k, b is equal to 6 and c is equal to 1. Discriminant b square minus 4ac greater than 0. B square 6 square minus 4 into a is k, c is 1. greater than 0. 6 square 36 minus 4k greater than 0, or 36 greater than, shift 4k to RHS, 4k, or we can take 4k lesser than 36, or k less than 36 by 4, 4 ones 4 nines, k less than 9, values of k are less than 9. Find the values of k for which the equation x square plus 5kx plus 16 is equal to 0 has no real roots. Solution: here given equation has no real roots. That is, discriminant of the given equation is less than 0. In comparing this with ax square plus bx plus c is equal to 0, here a is equal to 1, b is equal to 5k, and c is equal to 16. Discriminant b square minus 4ac less than 0. b square 5k whole square minus 4 into a is 1, c is 16 less than 0. 5k whole square 25 k square minus 4 into 16 64 less than 0. Here we required k, so we can take 25 out. 25 k square minus 64 by, we have taken 25 out, so here it is 25 less than 0. Here there is one condition, that is, if AB less than 0 and A greater than 0, then B less than 0. Here 25 greater than 0, and we can take this as B, that is less than 0. K square, since 25 is A, k square minus 64 by 25 as taken as B, then k square minus 64 by 25 less than 0, or k square minus, write in square form, 8 square by 25, that is 5 square less than 0. Here you know that x square minus a square less than 0, then this x lies between minus a and plus a. It is x lies between minus a and plus a. Here also k lies between 8 by 5 minus 8 by 5 and plus 8 by 5. Here k lies between minus 8 by 5 and plus 8 by 5.